Hello everyone. In this video we will continue to examine topic 12.1, the interaction of matter with radiation, and in particular we will follow up with the energy and time uncertainty principle. Alright, so the uncertainty principle was introduced as sort of a consequence of the nature of the wave function itself and wave function collapse. But as we've sort of hinted at all along the way, there are other variables which can be acquired using the wave function. And as a result, it shouldn't surprise us that there are other variables for which the uncertainty principle applies. Okay, these variables are known as conjugates, these pairs of variables. And in the most hand-wavy derivation yet, we're going to observe that the units of the uncertainty in the position and the uncertainty in the momentum can be rearranged to be the units of the uncertainty in the energy times the uncertainty in the time. And that gives us the energy-time uncertainty principle. Now, it is really important to recognize that unlike position, momentum, and energy, time is a weird variable to be in the uncertainty principle in the same way that delta x and delta p are. Energy makes a little bit more sense. It's basically, if you take a measurement of the energy, it will be within a certain range, with a certain probability. But time doesn't make a lot of sense. It's not the same kind of variable, exactly, particularly before relativity. And so we need a very, very narrow interpretation of this uncertainty principle to really feel comfortable using it. And this is the following interpretation. A qualitative way to understand energy-time uncertainty is that processes which violate the conservation of energy by delta E, okay, so there's an uncertainty in the energy that may be bigger or smaller, can happen, but they must do so in time delta t. And if delta E is bigger, that if the amount of energy by which the system would need to violate conservation of energy in order to make it happen is big, then delta t is going to be very small. It must happen incredibly, incredibly quickly. That's the way sort of to think about this. The energy of a particular state can be thought of as having that delta E, and then the lifetime of that state is delta t.